Assalamualaikum students. Students, we are doing today the delta H solution and hydration and the calculation of the delta H solution. And in the previous lectures, we have done Born-Haber cycle, the calculation of the delta H lattice, and the definition. Now this is the fourth lecture of the energetics, right? And to explain delta H solution, hydration, their definition, their calculation, the Hess law, I'm going to share my screen. But when I'm sharing my screen, you guys are supposed to like, subscribe, and share my channel. Okay. So 3, 2, and 1. Yes. I'm sorry. Now, look. What is the first thing is, what is delta H hydration? Yes, delta H hydration. You know what is delta H hydration? Standard enthalpy change of hydration. I will share the notes with you. And for the notes, as you know, that you have to go to my website, Chemistry by Zeenat. The notes and the topical past papers are given over there. Here, focus on the concept. Okay. Now, delta H hydration. Enthalpy change. Listen. Enthalpy change measured under standard condition when 1 mole. When 1 mole ions that are gases are dissolved in excess water. What? Excess water, infinite dilute solution. Like you put ions in water, there would be enthalpy change. Like it's kilojoule per mole. You know, per mole of what? Per mole of the ions that you are going to dissolve in excess water. The point is, when you put ions in water, why there are energy changes? The question is this. Because when you put ions in water, the ions, they become what? Aqueous, hydrated. Hydrated. Look, when you put cation in water, the cation are attracted by what? The O, no, not this blue, O negative. O negative. You know, water is polar. This polar water has the ability to attract cation and to attract anion. Right? Now, this is negatively charged. It's going to attract cation. And this water from every side, look, infinite dilute solution mean water is surrounding all the ions in what? In 1 mole of the ion. What is 1 mole of the ion? 6.02 into 10 power 23 ions are fully surrounded by water. The water attract. There is attraction. And that attraction is what? Exo. And that exo is the energy that is released when you put ions in water. Look, if I put anion in water, any anion, what is going to attract the anion in water? The H positive. The H positive. The H positive. So each ion should be fully surrounded by ion. This is look, ion, dipole, ion dipole interaction. See? Ion dipole interaction, attractive forces. And these are exothermic. Which type of ions are attracted more strongly? Which type of ions? You know this. The ions that are small in size with high charge. Huh? So, ions with small size plus high charge are attracted more strongly by water. Therefore, their delta H hydration are more exo. Now listen. If I have 1 mole of sodium ions, if I put this in excess water, the sodium ions are surrounded by water. If I have chloride ions in water, chloride aqueous, I have nitrate ions, nitrate aqueous. I have phosphate ions in excess water, phosphate aqueous. Will sodium has more exo delta H hydration or magnesium? How you will do this? I'm taking my coffee. Think about it. Which one has more exothermic delta H hydration? More exo. Look. Small size, high charge. The charge is clear cut, more with 2 plus. Okay. What about size? 11 proton plus 1, 10 electron. 12 proton plus 2, 10 electrons. See, the electrons are same. So the decided factor is what? Proton. More proton, more nuclear attraction, and size is small, Mg2 plus, sorry, have high charge. And small size attract polar water more strongly than Na plus. The delta H hydration of Mg2 plus is more exothermic. Same is the case with, like, look, if it is fluoride and chloride, we know fluoride is what? Small. It's above chlorine in the group 7. Down the group number of shells increase, the size is getting larger. Its size is what? More. So fluoride attracted more strongly by water. More exothermic delta H hydration. I hope you understand the delta H hydration. Now your next topic is what? Delta H solution. Yes. Delta H. Delta H what? Delta H solution. You know what is delta H solution? When you put iron in water, hydration, when you put salt in water, solution. Look, enthalpy change measured under standard condition. When you put 1 mole ionic solid, lattice solid compound is added to what? Excess water. The salt from solid become what? Aqueous. So enthalpy change measured when 1 mole of ionic solid is dissolved in excess water. Enthalpy change measured when 1 mole of gaseous ions dissolved in excess water is called hydration. Enthalpy change measured when 1 mole of ionic solid is dissolved in excess water is called what? Enthalpy change of solution. Now, suppose you have 1 mole NaCl, solid. You dissolve this in excess water, it becomes NaCl aqueous. And you can even write it this way. Na plus separate and Cl negative, it's up to you. Suppose you have potassium phosphate, solid. 3 potassium phosphate. Suppose you have barium hydroxide solid. The barium separate, the hydroxide separate. Or you can just write barium hydroxide aqueous, right? But there is a situation. It could be positive, it could be negative. Why? Because if the salt is insoluble, it is positive. If it is soluble, it is negative. Look, if I go to group 2, you have done this in AS, and now you are going to do this in A2. Like beryllium hydroxide, magnesium hydroxide, calcium hydroxide, strontium hydroxide, and barium hydroxide. Insoluble, slight or almost insoluble. Partially soluble, complete soluble, they're becoming soluble. Why? Because the upper have positive delta H solution, the lower have negative delta H solution. The delta H solution is getting exo. In the upper, it's getting endo, and it's opposite to sulfate. You know this. Like we know that beryllium sulfate and magnesium sulfate are soluble. Calcium, strontium, and barium sulfate. Insoluble, insoluble, insoluble. Why? The upper has delta H solution, exo. The lower has delta H solution, and. But how we can calculate delta H solution? Before going to calculate delta H solution, I want to show you the note so that you are familiar with. This is energetics. Look, this is your delta H hydration. Enthalpy change measured under standard condition when 1 mole of gaseous ions are dissolved in excess water. Ions in water, delta H hydration is always exo because the ions are attracted by water, cation attracted by water, anion attracted by water. Ions with small size and high charge have more exothermic delta H hydration solution when you put salt in water. Enthalpy change measured under standard condition when 1 mole of ionic lattice is dissolved in excess water. Now listen. When you put salt in water, the water attract the O attract the cation, the positive attract the anion. They help in weakening of the bond of this lattice. When this help in weakening of the bond of this lattice, the bond break. The ions are then what surrounded by water. The ions get hydrated. The ion dipole interaction they are formed. The ionic bond break. Delta H solution could be positive, delta H solution could be negative, right? If it is positive, insoluble, even positive or less exo. Negative or like if it is toward lower side, soluble, right? If it is positive, then it is what? Insoluble. Right? Toward negative, it is soluble. But now, how to find out delta H solution? But first I'm going to explain this over there, then I will come to the notes. Okay. As you know, my method, I hope with the best of time you understand that what is my teaching methodology. Now, listen, let me take my coffee. Sorry. Okay, look. Hess law. How you will do this? We are going to relate three things. Delta H lattice. When you make, look. Oh, wait a minute. I think this is much better. Look, when you make 1 mole of ionic lattice from gaseous ions, when you make 1 mole of ionic lattice from gaseous ions is delta H lattice. Like you are making NaCl from Na plus and chloride. 1 mole of ionic lattice. This is delta H lattice. When you put the lattice in water, this is called what? Look, lattice from ions, delta H lattice in water is called what? Solution. Doing it again. See? You are making 1 mole of NaCl solid from sodium ions, chloride ions. So you are making ionic lattice from its gaseous ions, delta H lattice. Like you convert the ions into lattice and you can put the lattice in water. So when you put the lattice in water is what? Enthalpy change when 1 mole of ionic lattice is dissolved in excess water is the solution. Yes. Look. When you put lattice in water, it's what? Solution. When you put ions in water, it's called what? Hydration. So, this is solution. Repeat it again. When one mole of ionic lattice is made from gaseous ions, the enthalpy change is called delta H lattice. When you put the lattice in excess water, you get solution. So ions are converted into lattice, lattice is converted into aqueous. Can we directly convert ions into aqueous ions? What you will call this? Think. Waiting for your thinking process. Tell me. Ions in solid. The solid is dissolved in excess water. The ions directly in aqueous ion. Ions in water. Ions in water. Hydration. Can we say that there are two routes? Aqueous ions or ions into solid into aqueous ions, and ions directly into aqueous ions. Two routes. Can we say that hydration is the sum of lattice plus solution? Can we do it this way? Look, these are gaseous ions. Gaseous ions. Look, from gaseous ions into solid NaCl. Enthalpy change measured when one mole of ionic lattice is made from gaseous ions. Delta H lattice. Lattice into water. Solution and ions directly into aqueous ion. Hydration of both ions, chloride and sodium. So can we say that this is start, this is stop? So there are two routes. One route and the other route. So can we say that? I want to do it this way. Wait a minute. Let me do it. Yeah, this way. And now look. Yes. So can we say lattice plus solution is equal to hydration? Of course. Lattice plus solution is equal to what? Hydration. Can we draw it for another salt like potassium nitrate? Not potassium nitrate, calcium nitrate. In calcium nitrate, there are two calcium. There is one calcium, there are two nitrate. Gaseous. First, and this is just one. It's not taking prediction. Wait. Yeah. Look. From gaseous ions into solid and solid in water is what? Solution. So can we say it's delta H lattice? This is delta H solution. This is hydration of one calcium. But Hydration of nitrates, how much? Twice. Why? Because there are two nitrates. There are two nitrates. But this is one more lattice. From its science, kilojoule per mole of the lattice and kilojoule per mole of the lattice dissolved in excess water. Here it's per mole of the calcium ion, and if it is per mole of the nitrate, so there are two nitrates, you have to use two times. So if we do a question of this thing, if I show you in these, look, this is the same explanation. Gaseous assigned to solid, aqueous, direct, and this way. Look in this question. Calculate lattice energy. But you are provided with what? Hydration of nitrate, hydration of calcium, and solution of nitrate. Be careful about what? Delta H hydration handling, because it is for ions. So count the ions in your salt. Like there is one calcium, there are two nitrate. So calcium 1 this. And you're supposed to do a lot of cycle, do these. I hope you will be able to do everyone. जितनी दफा repeat करना है repeat करो, watch it again and again. But I know if you will watch it even once carefully, you are in a position to do everything. Now, in this chapter, there are two other things. One is the bond energy data, the one you have done in your O levels AS. When you use bond energies, this is suppose your reaction. Look, this is your reaction. The bond energy of reactant minus bond energy of product will give you the delta H. There are questions in your P4 which are linked to this thing, right? But at the same time, there is another thing. Look, if in your question, these are your reactants turning into product, this is the delta H, which is unknown. Which is unknown. And in the question, you have the formation of the reactant and you have the formation of product. Like the formation enthalpies. You know what? Formation. So formation is what? When you have the formation, the formation of the reactant from its what? Elements. Look, you will write elements. From these elements, the reactants are formed. From the same elements, product are formed. Product are formed. It's a balanced reaction. This is formation of product. This is formation of reactant. If you look at the arrows direction, it's this way. Elements making reactants, look, elements making reactants, reactant making product, and element making the product directly. So isn't this two roots? These are elements, start. Why this is start point? Because there are tails. This is head and tail. This is both head. From tail to, look, head, and then tail to head. And this is, again, tail to head. So your journey in Hess cycle, like, you're not that young, not that small to understand a basic concept. Listen, don't go for tricks, nothing. always go for the vector sum concept, and your roots are decided by all. Look, from all, all tails to all heads. Your journeys, your roots are decided by this. From all tail to all head, there are two roots. Which two roots? This direct, one root, and this is another root. So what we can say? We can say that enthalpy change of the formation of the reactant plus the delta H is equal to enthalpy change of formation of product. Yes. Look, you can see all these in detail in my AS notes. They are fully explained that what you can do. Even I hope you are understanding it here too. Like, look, enthalpy change of formation of reactant in delta H. Delta H formation of reactant plus delta H are equal to enthalpy change of formation of product. So if I make it subject, enthalpy change is equal to enthalpy change of formation of product. I don't know what is happening in a fine part. It's 12 o'clock, something special. Okay. So enthalpy change of formation of product, this sides become minus. So you are supposed to know how to use the enthalpy changes of formation and bond energies. If it is bond energy of reactants minus bond energies of product. But if it is formation enthalpy, that is product minus reactant. Look at this. There are some questions that I have solved. Look, I have explained this. Reactant, product, formation. So formation of product plus delta H is equal to formation of reactant plus delta H is equal to formation of product, and this is your formula. So look at this question. These are reactant. Can you see the enthalpy changes of formation? Formation of copper oxide, formation of this from its element, formation of this, and this is the equation whose delta H is unknown. So what I'm doing? Enthalpy change of formation of product minus reactant, copper oxide. Value is how much? This 2 times NO, 2 times, 2 times, because 2 moles. Element, do you think, would there be any change if you are making O2 from O2? No, it's the same. So enthalpy change of formation of oxygen, we said 0. For me, I think it doesn't exist. It's not possible. Like, formation of oxygen means what? You're trying to warm oxygen, cool oxygen. It's the same thing, no difference. So formation of element, we say 0, okay, but this is given 2 times, this is given, and enthalpy change of formation of product minus reactant. What is the value of the reactant? This, and you'll get your answer for this same term. So now you're supposed to do practice. I hope you understand, but still if you don't understand, I'm telling you again and again, you can join my live sessions even. You can even contact me. All the information are on my website. For any particular question, you can contact me directly, right, on my WhatsApp number. It's shared with you on my website. Okay, Chemistry by Zeenat. I hope it's helping you a lot. Many prayers. Allah Hafiz.